Okay, so we are having a question that of the you can say that in the last video we are done with the ideal gas equation as well as the STP, and you can say that the value of our constant on STP SI unit, as well as we have done the ideal gas equation, that is PV is equal to NRD for finding a density or to calculate the density and the mass. So here we are having a problem that laughing gas N2 at 30 Celsius and 820 torr, which is pressure, occupies a volume that is 10.32. We have to find a volume at STB, that is standard temperature pressure. So here I can write that the temperature, that is 30 Celsius, T1 is 30 Celsius, and P1 is equal to 820 torr, and volume 1 is 10.32 dm cube, that is, and V2 we have to find at the standard temperature pressure. So to convert the Celsius into the Kelvin, or you can say that first of all let's talk about standard and temperature and pressure. So we can write here T2 is equal to 273 Kelvin. Okay, that is the standard unit, and P1 is equal to 1 atm. Okay, so that is STP, as you can all know. So here you can see that here the temperature is having the Kelvin unit, here the temperature is having Celsius unit, here the P1 is in atm, and here it is in torr. So you can say that we will do the unit same. So we will be converting Celsius into the Kelvin first of all. So to convert the Celsius into the Kelvin, we will be adding them, that is 30 plus 273, that is equal to 303 Kelvin. Now you can see that is the unit is having the same unit. If you're talking about pressure, so we are having a pressure that is 820 torr. As you guys all know, we were done with the conversion. This is same as the conversion. So multiply by atm, we are having 1 atm, and torr, you can say that 1 atm is equal to 760 torr. As you guys all know, in the converter I have told you everything about that. So 760 torr. So the answer is equal to 1.07 atm. Now you can see that the units are same. So we are having a three values, that is T1, P1, V2. So we can write the formula, that is P1 V1 T1 is equal to P2 V2 T2. Cross multiplication, P1 V1 T2 P2 V2 T1. Okay, we have to find volume number 2. So volume number 2 is equal to P1 V1 T2 P2 T1. Okay, P1 V1 T2, and here you can see that P2 T1 and volume we have to find. So put the values on that. As you can see that P1 value is 820 torr, or not 820, we are having a 1.07 atm that we find it, and you can say that the V1 we are having 10.32 dm cube, and multiply by, that is T2, that is 273 Kelvin, upon 1 atm, that is the P2, multiply by T1. We were having a T1, that is 303 Kelvin. We have find it. So you can see that atm will cancel by atm, Kelvin will cancel by Kelvin. Here dm cube is there, so you can say that your answer is right. because you have to find the volume and the unit of the volume is dm cube, and the answer will be in always dm cube if you are finding a volume. So after multiplying and dividing, so the answer is 9.94 dm cube of N2O. Okay, so we can easily write that the V2 is equal to 9 dm cube of N2. Okay, so here you can see that we are having a one more question, that is question number 2, that is calculate the density of oxygen at 45 Celsius degree with when a gas is in cylinder at 1.54 atmospheric pressure. So here you can write that we have to find the volume. Okay, or you can see that we have not volume, sorry, we have to calculate the density, we have to find the density. As you guys all know, we have found the two equation of with the help of the ideal gas, that it was PV is equal to nRT, and we have found the, you can say that the density and the mass too. So here we have to find the density, so we'll be putting the density formula. In yesterday's video we are done with all the equations, so you can watch that first, then you will be understanding all that. So here density we have to find, and you can see that the T, that is temperature, we are having 45 Celsius in the question, and pressure we are having a 1.54 atm. As you can see that this is in Celsius, we have to convert into the Kelvin. So 45 plus 273, that is equal to 2318 Kelvin. So formula we were having that, first of all you can say that you can say calculate the density and the mass with the help of equation, that was PV is equal to nRT. We have to find the density, so PV is equal to N, we are having number of moles here, but we have to find what density, so we'll be putting the density formula, that is M upon VRT. As you can see that mass per volume is the formula of the density, so mass per upon volume RT. Here you can write that PM is equal to DRT, that is what density, so DRT, that is density. Okay, so here we have to find the density, so density is equal to PM upon RT. Okay, so here we are putting a formula, that is you can say that D is equal to PM. First of all, P we are having 1.54 atm, 54 atm multiply by 32 gram per mole. As you can see that about the oxygen there is, so if you're talking about the mass, so that is 32 gram per mole divided by, as you can see that we are having a, you can say that we are having a, we have to find the at the STB. So as you can see that we have also finded the R constant value, or even R, what is R is a gas, you can say that ideal gas equation constant. So R is the constant. We have also finded the R on the STB, that is standard temperature pressure, as well as SI unit, that is SI unit. Okay, so as you can see that on the basis of the R, the STB value of the R was 0.0821 atm dm cube Kelvin inverse and mole inverse. Okay, that was the value of the R on the STB, and we are having a T, that is 318 Kelvin. So here we can see that ATM will get cancelled with ATM. Okay, you can say that the can you can see that the mole, gram per mole. Okay, so Kelvin will get cancelled with Kelvin, mole will get cancelled with mole. Here you can see what's remaining, that is dmq. We have to find the dmq density. Okay, so here after multiplying and divide, so the d is equal to 1.889 dmq, and that is what it is. You can, your question will be like that, your mind will say that why we have used the STP unit, or you can just standard temperature pressure on R, why not SI? But let me tell you guys, that is mostly we are using the in problems we are using the R constant to calculate the R constant on the STP. So we are mostly using the STP on R, not SI. But in some cases SI is also used, so that problem will be doing tomorrow. So today we have done the two problems, that is about the ideal gas equation.